Hi folks. So today we're going to talk about print optimization. So what do I mean by print optimization? What I'm basically talking about is how can we make sure that our process is, essentially performing the way that we need it to. All right. So and we really have to optimize our workflow if we want to do anything complicated. And when I say complicated, I'm talking about halftones, but it also could very well reflect things like accurate color representation. So if you want really good quality process color work, well, we need to optimize. If we want to be able to control our halftones appropriately, then we need to optimize. Now the thing is in order to get good quality process color printing on a flexo press, there's really three stages that we need to go through. The first one, and I think a lot of people would say the most important one, is optimization, because if it's not optimized, everything you do afterwards is just kind of goes out the window. So the first thing that we're going to talk about is like what are some of the tools that are involved with the print process. How do we monitor what we do? How do we quantify, the things that are occurring through the process? So if all your tools are out in the tool shed out back, we need to go get them. And let me tell you which ones that we need to have. So first off, we need to make sure that we're using our tools properly. Obviously, my friend Sean here has no clue what he's doing with those tools. But that's not really good. Good thing that Sean doesn't work in construction. But the purpose of our tools is to measure and control our process. This is what gives us repeatability, and it's what keeps the process calibrated. You think of calibrated as a fixed, unmoving state of a process or a workflow. The thing is we don't want to introduce variables into the workflow that would disrupt that balance. So our tools are going to help us stay within that range and monitor and make sure that there's not variables that have been introduced that contaminate the process. So first off, a ruler. A lot of us kind of ignore this sort of thing, but having one on hand is always a good idea. It's a nice way to be able to just to double check everything we're doing. So now I'm not going to spend a whole lot of time on how to use a ruler here, but it is something that a press person and actually anybody working in the Flexo workflow should have access to, and should be something that you use on a regular basis. Here we go. Here's a bad boy. This is a spectrophotometer. So a lot of times people refer to these as a spectro. But what a spectrophotometer does is that it measures colorimetric data. What colorimetric data is essentially it evaluates color on a very grand scale. It measures color extremely accurately. So I'm not going to go into depth about how it measures color, at least at this moment. But what I want you to know is that this device here, is designed to measure color. So if you are trying to print process color, or you're trying to match a particular Pantone color, you're gonna need one of these nearby. It's something that the press operator should have on hand. Any kind of ink formulation person needs to have on hand. Also, these devices need to be calibrated. Now, this right here is an image of the spectrophotometer that we have in our lab. It's an X-Rite exact spectrodensitometer. But then the thing about it that you need to know is that these have to be calibrated, and they need to be calibrated on a daily basis. Now, it's just an well, the nice thing about this particular device is that it won't let you use it unless you calibrate it. So, and it kind of does it automatically. The first time you go to use it, it's going to say a calibration needs to be made, and it says put in the cradle, and then you hit the button and it goes and calibrates. It's not a big deal. It just takes a few seconds, but just make sure that it's done. Because what this does is it establishes a reference white, and basically it kind of just zeroes all the numbers in and just makes sure that when it does a reading, it's a reliable, accurate reading. Okay. Also make sure that whenever you are doing a reading that you're using the proper measurement settings, and that whenever you're doing a measurement, it's usually a good idea to take a sample and put it on top of a white sheet of paper, because what you won't want to do is take a sample and then lay it on like a dark table and then do a reading, because that could influence how that reading is happening. Because, a lot of our substrates aren't, 100% opaque. They're going to show through a little bit of whatever they're laying on top of. So what's important is having a consistent backing that you lay your samples on top of whenever you're doing a sample reading. So I have one of these on hand. So here's just an example of how this works. Very simple and easy. Voila. How easy was that? And then it gives us a reading of that color using LAB. For right now, I'm not going to go into the depths of what all that means. We're going to get to that later in this class, but for right now, just realize it's something that you need to use. Now, this device is called a densitometer. Now, a densitometer and a spectrophotometer are two separate things, or they're designed to do two separate things. Now, the device that we have in our lab is called a spectrodensitometer. So that means it's kind of like both devices in one, which is really convenient. So the device we have in our lab, it'll measure color, and then it'll also measure density. So what you need to understand about a densitometer is that what it's really used for is to measure how much ink is being printed. It doesn't measure its color. It just measures how much ink is being printed. So, and the way that it does that is that it measures how much light is being reflected off a sample. So you think about this. A darker printed sample is going to reflect less light. So it's going to actually have a higher density. Density is defined as a print sample's ability to absorb light. So however much light is being reflected off of it is an indicator of how dark it is. And usually how dark something is a direct reflection of how much ink's being printed. So that's what a densitometer is used for. So if you hear something like SID or solid ink density, these patches or these things are measured so that it gives us an indication of how much ink is being printed. So think about this. If I'm printing, a Pantone color one day and I do a little bit of I do a little density measurement on it, it won't tell me anything about the color, but if I go and I run that same job next week, I can then go and measure a patch, a solid ink density patch on our print, and that'll give me an indication of whether or not the same amount of ink is being printed. Now, and this is especially important if we're printing process color, because when we're printing process color, the same amount of cyan, yellow, magenta, black, every time we run it, we have to be pretty much printing the exact same amount of ink each time. Otherwise, we're going to have color shifts. So this is a way for us, an extremely important way for us to monitor our process on press. So, a loop. If you don't have a loop, you don't have a magnifier of some sort, it's time you round one of those up for yourselves. I mean, you could order one online. You can get these nice fancy ones that are metal, or you can go to the dollar store and just get yourself a magnifying glass. A dollar store magnifying glass will work just fine. what this does is it allows you to visually inspect a print sample for a variety of things, like how good is your registration? Are the dots, reproducing in the correct shape? Do we have overimpression? Or is there any slur occurring? Do we have a nice even laydown? And a lot of times, if you look at that, just with the naked eye, I mean, most of you guys are pretty young. You can see things pretty good, but the help of a magnifier of some sort is essential to your toolkit. All right, here we go. Now this is a tool that you may not be aware of, and we're going to talk about a scenario more in depth later on in this about how a banded analox roller is used. So what a banded analox roller is like, I know all you guys know what an analox is, but if you look at this roller, you can see that there are multiple bands going across this roller, okay? Each one of these bands will transfer a different amount of ink. So it's like kind of having it's kind of like having, in this particular case, we've got 1, 2, 3, 4, 5, 6. We've got 6 bands going across this analox. And it's like having 6 different analoxes all in one. Now, this is not something you would use for production. I mean, you could maybe figure out a way to do it, but I feel like it's pretty unlikely that you could ever use it in production. This is solely for testing and optimization of your print process. It saves time, saves money. You'll see what I mean a little bit later. All right. If you're not measuring the pH of your inks pretty much every time you're using them, you're running uncalibrated. You're running in an environment that is not controlled. So make sure you've got your pH meter. Make sure that you're testing the pH of your ink, especially before you start, but also throughout a long press run. I think we all know that the ink should be, 8.5 to 9.5 in that range of pH. What I always do, especially when I start, is I adjust to that 9.5, or you can even go a little bit beyond that 9.5. Maybe you go on up to, let's say, closer to that 10 range. That's okay, because what's going to happen is throughout that press run, the pH is going to drop through evaporation. And so if you start kind of on the high side, you're going to stay in that window for quite a while. But it's very important that you start, at the upper end of that window. Also, Zahn cup. So Zahn cup tests viscosity. What is viscosity? Viscosity is a liquid's resistance to flow. Now, generally, in the Flexo water-based ink world, we use a Zahn cup number 2. We use number 2, and what that tells us is that the 2 indicates the size of the hole in the bottom. Make sure that Zahn cups are in good condition. They're clean, they're no dents, it hasn't been dropped. And you're also going to need a stopwatch as well with this, as well, because you're just going to measure how long it takes for the ink to run out of a Zahn cup. I probably need to make a video on how to measure viscosity, but it's very easy. Doesn't take very long. And the thing is like, if your pH is good, there's probably a very good chance that your viscosity is also good as well. Whenever the pH goes out, viscosity a lot of times goes out. So something just kind of think about, but it's just one more tool for us to monitor our process. Another extremely important tool is the first book. So the first stands for Flexographic Image Reproduction Specifications and Tolerances. So, there's an old version of this book that you can reference on the Blackboard shell. But for the most part, what I want you to understand is even that old version, even in heck, I think it's on version 6 or 7 now. What it is it's a guidebook to keep you, it's reference. Like, what should be your aim points? What should be your targets? What kind of densities should you be hitting? What are some specifications of your plates? Those sorts of things. And also, what's the proper process that flexography should be going through from start to finish? So the thing is it's called specifications. The term specifications, what you need to understand is it's a recommendation. It's not a standard. There's a difference between a specification and a standard. A standard says it has to be this way every single time, no deviation whatsoever. Well, with the first book, it's not a standard. It's a specification. So it's a recommendation. Like, this is a really good starting point. But if this starting point isn't achievable for some reason, well, try to get as close to it as possible, and then always hit that same mark over and over again. So it's a recommendation, not necessarily a rule. And if you get to know this process, it really, really helps. So having access to this book is very important to understanding the Flexo process. Also, documentation sheets, super, super important. I hate to say it that we're kind of slack in this area. And, and it's something that I don't necessarily enforce quite as much as I need to. But if you want to repeat something, you need to have all of the details. You really can't repeat something if there's no way to remember all this stuff. So if you write it down, document it. You can document it digitally. You can document it by hand, like Dan here is doing. But even if you do it by hand, then you can go snap a picture with your phone, and now it's you got a digital form of it, and you don't have to keep that sheet anymore. But the point is that you need to be able to recall all of the stuff if you want to repeat it. And again, that's what our goal is. Our goal is to be able to fix our process, and that process will be the same way every time we do it. So extremely important. Also, keep in mind that, there's team members out there. I mean, you've got support. If you are doing a project and, you don't understand something, or you're having issues, or there's problems, well, there's a really good chance I know somebody that can help you. Also, think about your LinkedIn account. If you start reaching, let's just say you're having a problem with plates. Randomly reach out to somebody that's a plate person. It could be a complete stranger. Try to connect with them. When you send a connection, put a little note. Hey, I'm a student. I'm having some issues. Would you take a few minutes out of your day and help me out? I tell you, I bet you if you send out 3 of those, I guarantee you one of those 3 is gonna reach out to you, because this industry really wants to support education. And the people that work for supply companies, like ink companies and plate companies, they're very open to this sort of thing because we have a good reputation in the industry. So, don't assume you can know it, or don't assume that you can figure it out on your own. Save yourself some time, contact somebody, ask a question. There's nothing wrong with that. All right. So let's kind of take a little bit of a deeper look into optimization. How do we optimize? So the thing is like, we need to understand some things. First off, we got to have a plan. So the thing is like, we got to have a goal. Like, what are we trying to do? Are we trying to reproduce an ink properly? Are we trying to reproduce a color property? Are we trying to print process color? Do we want to find out if we change the speed of our press, how does that impact our final print? So the thing is like, if we're going to optimize, we need to have a plan of what we're testing for. So what I want you to think about with the whole idea of optimization is that we need to have a goal, and we got to have a plan of how we can identify what's going to take us to that goal. So we need a plan. And then what we need to do is that we need to test out that plan. So we're going to run print trials. Now, I say print trials, but this may actually occur in the plate making room. Let's just say like we're going to adjust our exposures so that we hit a particular floor height. It doesn't necessarily be print, but basically we're going to create an experiment, and we're going to find out how that experiment is going to lead us to the specification or the goal that we're trying to hit. And we're going to have to collect some data and document those results. So once we've gone and done the experiment, we have to evaluate that experiment and then identify, what worked out best for us. So when we look in the first book, section 1.3.1, press optimization, in this book, it shares a guide on what we should be doing. So it kind of demonstrates an optimization test plan. It talks about print trials. It talks about the optimization of data collection and documentation and whatnot. So, but essentially, what I'm gonna do here is I'm gonna kind of give you an overview of this concept. But this is also detailed in the book. Man, it sounds like I'm selling this book, isn't it? I tell you. So, what are we gonna identify during the test planning stage? We're gonna figure out that goal. So we have to look at variables to evaluate. So, what variables are we going to change to see how that impacts our print? So we need to identify what variables we can adjust. And we got to also create a method of evaluation for that plan. So how are we going to evaluate it? We're going to test elements to use to determine optimum combination of variables. Because you think about it, in Flexo, our end product is based off of, a wide range of variables. You think about how many variables can go into a Flexo print. You got your inks, you got your substrates, you got your plates, you got, how did you image those plates? How did you process those plates? What kind of mounting tape did you use? What kind of press speed did you use? What's your press, impression? What analogs did you use? There's so many variables that can go into play that can change the output of the press. So, the best thing to do is to gather up the stakeholders of the process. So, here at school, maybe that's you and another student that teams up. You sit down with myself or Amber or all of us, and we start kind of talking through some of these things. Well, who knows? Maybe we have some questions about inks. Well, maybe we should call up somebody over at Sun Chemical and say, hey, can you join us for this meeting? Maybe we got questions about substrates. Well, we'll call up Avery Dennison and say, hey, guys, do you have a tech representative that could answer some questions for us? These are the things you do. You need to assemble a team and think through this process. So here's some things to kind of keep in mind that'll make your optimization plan more successful. So when you're running trials like this, usually what you want to do is a maximum of 3 variables. And this is what's recommended by FIRST. Now, the reason they're saying a maximum of 3 variables is because, man, if you start getting beyond 3 variables, it can turn into quite an ordeal. So you want to kind of minimize these. If you want to test out more than 3, well, maybe break it down into smaller chunks. Because if you try to achieve all of it all in one, it's a recipe for disorganization. Let's say that, and it's opening the door to some things going sideways. It's best to identify just a handful of things and work with them. Another recommendation is stick to one color if possible. So, and what I mean, what is meant by this, and what the first book recommend, or what they're getting to, is that it's minimizing variables. So, you know, it's probably not a good idea to say like, oh, you're testing out a new substrate and you want to see how the ink adheres to it. Well, there's no real point in printing process on it. Just print one color on it. Just print one color on it and see how that adheres, and then kind of extrapolate the information you get from that trial to the other colors. Pretty much if one ink sticks or adheres, then they all will. But that's just an example. If it's possible just to do it with one color, don't make it difficult on yourself. Just kind of identify what's important and stick with that. Define other constants. So the thing is like, if we're going to go adjust, let's just say these three variables, identify what else is going to be constant. You know what I'm saying? Like, for example, if you're trying to test, the color, how process color, reproduces on a particular substrate, well then, let's just say you want to try 3 different substrates or whatnot. The thing is like the plates, the analogs, the inks, the mounting tapes, the press variables, those are all the constants. And those need to be very constant. And identify exactly, what all of those should be. And then that way, it's very clear, like, this is what's stable, and this is what we're manipulating. That way, there's just less confusion, and everybody that's involved in the process will have have a clear understanding of of what you're trying to define. If you understand what I'm saying. Okay. And then define exactly how you're going to set up and you're going to run the print trials. So this all kind of goes into the plan. The more planning that you put into this, the more clearly defined everything's going to be, the better and more accurate your results are going to be. So here's an example. Example A. So in this particular example, process printing banded analogs trials for a new substrate. So I kind of mentioned that before, right? So we want to see, so let's just say we're a print company and we want to print process color on a substrate that we've never used before. Now, different substrates are going to react differently. Some of them are coated and they're not going to be very absorbent to the ink. Some are going to be uncoated and the ink's going to absorb down into it. And the way it absorbs or the way it sits on top of it, it can be very different. So how are we going to do this? Well, we're going to use the banded analogs roller. And so essentially what we're going to do, we're going to use the banded analogs roller like we saw earlier. The variable will be 6 analogs bands going across this. So what that's going to tell us is like, this is how the ink's going to print off of 6 different, most likely volumes of analog bands. Some of the constants are going to be press speed, our mounting tape, the plates, the ink. None of that's going to change. It's going to be the exact same. And then the run conditions, how we're going to do this, it would be like run 1,000 feet and pull samples at 3 different intervals. Because one of the things that you want to do is like, you don't want to just pull one sample and just go off that one sample, because a job can change throughout a run. 1,000 feet is a pretty good example of, any job that we do in our lab rarely is 1,000 feet. But if you're out in the industry, 1,000 foot is representative of, time on the press. And if we pull 3 different samples, we can kind of see if there's any deviation between sample 1, 2, and 3. We can measure all 3 and average them. And that will give us, let's just say a more accurate or a better, what's the word I'm looking for? It'll give us a better kind of average of what the press is going to do given these variables. So evaluation criteria for each band. So, here's just an example of what a band analog may do. And what it would, we'd have, probably very little ink here, and different volumes of ink. So 1, 2, 3, 4, 5, 6, and then 7. Now, one thing you've kind of noticed about this particular band, or this particular one, is that there's kind of like this. There's a 1,000, 1.8 on both sides, and then there's 5 in between them. The thing is this is fairly common in the industry, just to kind of have like a constant, something that's across the board, so you can kind of evaluate if things across the web are consistent. Because if you do a measurement for this one and you do a measurement for this one, well, if there's a deviation between them, something's wrong, and like, let's just shut things down, figure out what's going wrong. Because if this one's different than this one, then you're not consistent. There's something, there's constants out of play that we need to identify what those are and stabilize before we really do this test. So that's pretty common. So in this particular example, again, we're kind of shooting for process color. Well, really, the most important thing that we're going to really be shooting for is the solid ink density. Now, I mentioned this before. How much ink is essentially being printed. So we need to kind of have a target for this. And what I mean by that is, how much cyan ink should we be printing? Well, guess what? How much should we be printing? What should be the density of our cyan? Well, we can go look at our first book, and our first book will tell us that, a good target solid ink density for cyan and process color printing is, a particular density. I don't have that memorized off of my head, but I can go reference it, in my first book. So that's going to be a very important thing to test on each one of those bands. We also want to take a look at dot area or dot gain. So we probably have a halftone patch on there, and just to see what kind of gain we're getting. Now the thing is, if we're getting a lot of gain, we can always adjust that in the next stage of process color, to achieving process color, which is called fingerprinting. And we'll talk about that another time. But we need to evaluate now, is there excessive gain that's happening? Because you think about it, like on this one right here, like on this one band, we're probably going to have some, that's a lot of ink for process color printing. And and that might be something that kind of eliminates. So if we have a whole lot, we can cut it back, but if we're getting a whole lot, there's probably a problem. There's probably a problem there. So another thing to kind of keep in mind with a banded analogs or a trial like this is, like, you want to see failure. Failure tells you that things have gone too far, and you want to see failure at both ends of the spectrum. And what you really want to do is, like, all right, it's failing at this end, it's failing at this end. Where is it in between? Where is it good? You can tell, like, success is always in the middle of failure. So that's helpful. So another thing that we want to do is, like, we want to make sure that it's holding, that's holding text reversed out and positive as well. There's not much point of having good accurate color if it's not going to reproduce our text well. Our text is extremely important, so that's something that we probably want to keep in mind. Also we want to see how are the dots printing, are the dots bridging in some point. And bridging just means, like, when two dots that are next to each other start connecting, and that usually comes from too much ink. So are the dots laying down smooth and clean? So those, these are the kind of things that we're going to evaluate from this print trial. So we create a test file that fits the evaluation goals. So here's a a good example. So notice that there's, we've got multiple, images that are the exact same. They're going to go across the plate that would match up to the bands of our banded Analux roller. So the things in here, we got a good, nice solid over here. We've got, that would, handle our solid ink density. We've got, halftone. We've got tone scales here. This one in particular has different LPIs. This, this would also give us an insight on what the best LPI to use on a particular Analux setup would be. And then we have some stuff in here that also would kind of help us evaluate how clean it's printing. How well is it holding the detail. Okay, so this is a pretty, there looks like a lot of stuff on it. It looks kind of complicated. It looks, like there's a lot going on here, but really, it gives us a place to do some evaluation and for us to get a couple measurements off of it. So, all right, so with this, we'd go and run it, and we just kind of stick to our plan, and then we could go evaluate it using our measurement tools. So here's another test plan example. Let's see. The ideal mounting tape and plate for printing white inks. So, some of the variables, we're going to use 2 different types of plates, 2 different mounting tapes. Constants would be the press speed, the Analux, and the ink. Probably also another constant would be the substrate. And then we're going to do our run conditions. This time we're going to run for 5,000 feet. Same cylinder, fresh tape. We're going to reset impression, 3 samples. So, essentially it's very similar to what we said before. We're going to identify what's a good example of press usage, pull multiple samples from it. When we pull those multiple samples, we would then, have a kind of an averaging across the entire print run. And then we would evaluation criteria for each combo. So what we need to do is, plan out this run. Because we're going to run 5,000 feet at each one of these. So 5,000 feet with plate A, tape A, get 3 samples. We'll repeat that with the different tape. This time we'll do it with, a different plate and a different tape, and so on and so forth. So in the end, we're going to pull 3 samples from each of these, run 5,000 feet of each of these. So this would take 20,000 feet of material. Now that sounds like a lot for us, but, let's say if you're trying to get set up for, a press run that's going to make tens of thousands of dollars, that's just a drop in the bucket to make that happen, okay? Just something to understand. In the way that we're going to evaluate this is we're going to evaluate for opacity. How opaque is that white ink printing? The weight. Basically, like, what's the weight of the ink that's being laid down? We're going to do a visual inspection of it. How clean, how smooth is that ink laying down? One of the kind of side effects of flexo printing is that there's sometimes mottling, which is a slight unevenness of the ink laydown. And we need to inspect that. There are ways to quantify it, but usually that's evaluated just by visual means. And also, is there any buildup that occurs? Because a lot of times, especially when you're dumping, when you're printing white ink, you're using a lot of ink. So, is there any buildup that occurs on the raised areas of the plate? How bad is that? Is that going to cause a problem during the print? So those are things that we need to consider. So we're going to create a test file to fit these evaluation goals. This one is going to be a little bit different. So again, we were evaluating plate, and we were evaluating mounting tape. So essentially, really, to do this, we just need some solids. We need to print some solids. We're not using a banded Analux roll this time, so we just need to see, how the press is printing solids, and voila. So, we have two plates that, are different, there are two different plate types, but they're made exactly the same. And essentially, we're just evaluating the solids. So the goal, of these print trials is to create a bunch of samples. This gives us this gives us exact representation of what's going to do, of how the press is going to perform when we're given these variables. So we need to evaluate and then identify, which combination of variables gave us, the best results. So some tips for, the running of the print trials. So if you're working in a production environment, try to incorporate this into the production schedule. It's something that definitely needs some planning. If most likely the press that needs to be tested the most is the one that's probably being ran the most. So at the end of the day, we still got to pay our bills. We still got to make our clients happy. So try to incorporate this so that it's not a disruption in the production schedule. Make sure that everybody that's involved is aware of what's going on, so that that everybody involved has a clear understanding of what their role in this print trial is. Run in production conditions, but verify raw materials used. So what this is trying to say, what the first book is trying to say by this is, run things normally. Run things normally, but just double check that your normal operation is appropriate. Okay. The thing is like, what you don't want to do is like, we're going to run this real important print trial. Okay. So we got people coming in from Sun Chemical. We got people coming in from Harper, XYZ. Like, let's go clean everything. Let's make sure that the press is pristine. Let's go clean all the analoxes. Like, let's make it perfect. Okay. Because I'm nervous about this and I want to make sure that this print trial goes perfect. So you go run a print trial in those conditions. And you get some information and you base your judgments of how the press is going to perform based on this situation. Then the real job comes through and everything's back to normal. The consultants aren't here. We're like, the press is, it's clean enough. The thing is like, so there's the fallacy in that, is that don't do anything for a print trial that you wouldn't do for an average everyday print run. Because if you do something in the print trial that's, above and beyond, if that above and beyond doesn't occur during the general print run, all the information that you got from the print trial is useless. So run things normal. Run it like you would every single day. And also make sure you document everything and label all your samples. The worst thing that could happen is that, your samples get mixed up. If your samples get mixed up, you can guess which one was which, but is that really what you want to, put, possibly tens of thousands of dollars of investment behind? So things to be organized. That's, if you're going to go above and beyond on any of this, labeling and documenting what you're doing, that's a good place to go above and beyond with a print trial. So I already mentioned the document conditions. So, hit everything on that print documentation sheet. Make sure that you're hitting all those things. Even if you don't normally, measure the LAB values of the CMY overprint, during this one, go ahead and do it. Go ahead and do measurements. Fill out all of it. On a general print run, there's definitely data here that you don't need for every single job. So like for example, documenting the number of lasers that are in your plate maker. That's never going to change unless you go get a new plate maker. And if you get a new plate maker, well, you're gonna identify that. So some of these things, in my opinion, are not something you have to, do every single day, because it doesn't change. It shouldn't change, unless there's something drastic. And if something drastic changes, then all of it's going to change. So, but, cross your T's, dot your I's. Some extremely smart people made up this operating data sheet. People that know a whole lot more about flexography than I do. And it was a team of, let's just say the best minds in the industry that developed this. So just hear them out for this, This makes the team think through the process. That's another really good thing to note, is that if you're documenting all this information, everybody that's involved is going to be more clearly aware of what's going on. It's going to make them more appreciative, or more, connected with the variables. So identify your samples. Build a unique identifier into the plate graphics. So it's a really good idea. I mean, an example would be if you're, testing, let's say, a banded Analux roller and the solid ink densities from a banded Analux roller, on that plate that has the same image going across it, well, right below it, at the bottom of it, what the volumes are for each one of those bands, just incorporate it into it so that, you can't screw it up. Make it easy for yourself to be able to identify how the variables interplay. So if that's something you can incorporate into the plate graphics, go for it. Another way to do it would be, we are Flexo printers, right? So pre-print some labels or create individual folders for samples so that, we're staying organized. Like I said, organization is key here. Again, it could be something as simple as like this label right here. Okay, stay organized. So we need to collect our data and our documentation, which is really our goal. So data collected is analyzed, and best settings, the job and the press, are documented for subsequent fingerprinting. So that's straight out of the first book. But anyway, basically what it's saying is, like, you analyze this data to figure out what the best settings are, and we're going to document those best settings. And when we say settings, I mean the combination of variables. And we're going to document that so that when we come back for the next round, the fingerprinting, all of this will be established and it'll be very easy to follow. So some tips and suggestions for this. You can use software. Like for example, there's graphing software that you could use. Very common. And if you have access to that, it makes life a whole lot easier. You can also overanalyze things. And I mean, the thing is like, whenever let's just say again, we're going back to that example A, we're really trying to identify, what Analux volume is going to give us the proper, solid ink density. So, you can start analyzing too much. You can really start overthinking. Stick with the plan, have the goal, make that goal thoroughly understood, and then don't start overthinking it when you start documenting this. When you start calculating all this data, it can become overwhelming, and it also can be a distraction of what the actual goal is. So remember, just stay focused. Don't change the constants. That will disrupt everything. So, if you're going through your samples and you start noticing that one of the constants is a problem, realize that, the data isn't accurate at that point. So be aware, keep an eye out for anything that seems unusual. And then that way, again, you don't have some false belief in some of this data. Because really if something changed, or, one part of the print trial didn't go right, that part needs to be omitted. It needs to be redone. And maybe that doesn't throw off the entire print trial. But the thing is you got to be aware that the constants have to stay constant. If they're not, the data is not, it's not usable. Document the optimum settings for the key print and press variables for the job. So, at the end, evaluate it, identify which one looks best, what gives you the right, numbers, what visually looks the best, identify it, and clearly document that information. Because really what's kind of crazy is that, we're going to go through this entire process, we're going to, all these variables are going to test, and you're going to have all these samples, but at the end of the day, we're just looking for one of those. We're looking for one. And it's almost like the output is going to be kind of underwhelming. But at the end of the day, we'll know that that combination is going to give us the proper data or the proper representation of whatever we're trying to identify in the end. So when we're doing data analysis, like I said, if you can graph it and give it a visual, it really makes things easier. You can do this in Adobe Illustrator. Like a very underutilized part of Adobe Illustrator is its ability to graph data. So if you just kind of go make it can be a really simple and basic Excel spreadsheet of the data. You can take that, you can import it into Adobe Illustrator, and it'll create a nice little graph like this based off the data. It makes it very easy to use. And maybe it's a good idea to look at that data graphed in two different ways. And the thing is it makes things kind of stand out a little bit more in the end. So, and being able to see a visual, especially if you have to present this to somebody, graphs always go a long way. People love graphs. They just do, especially in a presentation. So if you have access to it, not only will it look good in a presentation, but having a visual of what's going on helps to make some decisions. So, and another thing to keep in mind, so we kind of did a data analysis. Well, here's a visual analysis. If we can have some close-up look at what they're looking at. I mean, because when we look at this looks like garbage. Look at that H. It's getting filled in. That's no good. Over here, it's looking a whole lot better. Kind of look at these things and evaluate what looks best, what gave us the best. How does it look to you? What's your gut feeling? This is one instance where your gut is a good thing to kind of go off of. And then, of course, your documentation. This is just another way of documenting things, which is pretty much almost identical to the first chart. So, in summary, optimization is the process of determining the best variables for a job. It's completed in 3 steps: create a test plan, run the print trials, collect data, and document the results. The only wrong way to do it is to not do it. I don't necessarily agree with that because there's plenty of ways to screw this up. But the thing is what this is trying to say is that it's much better to know what's going to happen before you have a live job. The last thing you want to do is go and try to run a live job and kind of work backwards, because what that's going to do, it's going to create a ton of waste. It's going to waste a bunch of time, waste material, manpower, all this sort of stuff. I mean, and the thing is once you start running a live job, and say something's not just right, well, then you start like randomly changing variables. Like, oh man, my cyan's printing too dark. Well, let me switch out the analogs and see what happens. That's not the time to do it. The time to do it is beforehand. Know exactly what is going to happen before that job goes live, and that way it just makes the whole situation better. So the wrong way to do it is by saying let's just move forward with this job and we'll figure it out on the press. That's the wrong thought process, because Just because you expect something to happen doesn't necessarily mean it is. Especially when there's a lot of money on the line. That's not the way to handle it. Okay, and that is one of the biggest issues I would say in Flexo is that people make a lot of assumptions, and those assumptions wind up costing a lot of money when they could just run a little experiment, see what's going to happen, know what's going to happen, expect what is going to happen, and base those expectations on data. So that's the whole idea right there. That kind of sums up what I was going to talk about today. Ran a little bit longer than I expected to, but I hope you learned something. Talk to y'all later.